So students, welcome back to this channel. And today we are going to be continuing Determinant series. Today we are going to be learning about a very interesting stuff, that is minors and cofactors. First of all, I'm crying, I'm just going through a fever, so that's why there are tears in my eyes. So I don't think it would assume that I am going through the emotional breakdown or something like that. No. Okay. Let's say I have a matrix A with the elements A, B, C, D, E, F, G, H, I. Now here, each element has its minor and cofactor. For example, the element A, the minor of that would be a determinant created, with the elements that are not part of the row or the column that our element, which in this case is A, part of. So the minor of element A here would be this determinant containing E, F, H, I. E, F, H, I. Okay. This way you can find minors of any element. So let's say talking about this element E. So the minor of this one would be we have to exclude the row and the column E is part of. So we have to exclude this row and this column. And what are we left with this A, C, G, and I, and we have to create a determinant with these elements. And that would be the minor of this original element E. So the minor of E would be A, C, G, I. This determinant. Okay. Let's let me give another example. Let's say we're talking about this element I. We're gonna be excluding the element I is excluding the rows and columns the element I is part of. So what we're gonna be left with is this row and this column, and the elements that are left with are A, B, D, and E. So the minor of I would be A, B, D, E. Okay. Now we know how to find out minors of each element. Now let's talk about what are cofactors. Let's talk about our very first element A. Minors and cofactors are very related to each other. Cofactor of A. Cofactor of A would be cofactor of A would be -1 to the I plus j. I plus j times m a in suffix. So what does this expression even mean? Here I is the row that the order of the row that our element is part of, and j the order of column our element is part of. This basically shows the order of the rows and the columns our element is part of. And we are going to multiply this quantity minus a to the I plus j with m suffix a, and this is minor of it. This is minor of A. A more generalized version of the like something like this: A to the A suffix ij, and over here as well A suffix ij. This is a general element of a matrix. So for this particular element A, the cofactor would be both I and j are 1 here, so it would be 1 plus 1. We would have minor of A. So we have minus 1 to the 1 plus 1, that is 2, minus 1 square. That is going to be just 1 times minor of A, that is E F H I. Okay? So this means the minor of D would be minus 1 to the 1 plus 2, since D is one of the first row in the second column, so it will be minus 1 times minus 1 to the 1 plus 2 times minor of D. Okay? Let me actually show let me write it down. Cofactor of D is minus 1 to the 1 plus 2. 1 is the order of the row that D is part of, and 2 is the order of column that D is part of, times minor of D, which will be the determinant created with the elements excluding the row in the column or element D is part of. So this determinant would look like B, C, H, and I. Okay? So this would just give us minus 1 to the 3, 2, 3. So this would just be minus times this determinant ACHI. Okay? As simple as that. This topic, minors and cofactors are very simple. I don't think there is even a little bit of complication into that. Basically, these are minors and cofactors are basically our way to basically a way to explain why determinants look the way it did. The value of determinants, the calculation of getting us to the value of the determinant looks like the way it did too. Okay, I'm gonna end this session today. If you guys have any doubts in the conversation, then please do let me know about that. I'll try to resolve that. Until then, keep learning.